This is the second session on data structures. Here we are going to discuss about the implementation of algorithm, the characteristics of algorithm, and how important are algorithms for implementing data structures. Algorithms are very essential to the implementation side of data structure, or we can say that data structures are implemented using effective algorithms. The algorithm can be implemented in any language of your choice you are comfortable with. The language is not a concern for designing a particular algorithm. The algorithm must be clearly stated how and where the data is being manipulated, what is the logical organization of data. So all these things are very important for algorithms. Now, what is the definition of algorithm? As we know, algorithm is a set of instructions written for explaining a particular problem solution. For a program, suppose you are writing a program in English like language, that is the set of instructions that will be executed in the in the program will be written here. So that is the algorithm. And if you see the official definition of algorithm, it is a finite sequence of instructions where each instruction has a clear meaning and each instruction can be executed within a finite amount of effort and within a finite amount of time. So set of instructions written by one after another is called an algorithm. So any problem can be solved by using more than one algorithm. Every algorithm can be written in its own way, and as we know, for any problem there are many mathematical solutions. So which solution must be chosen is according to the user and according to the effectiveness of the algorithm. So set of instructions written one after one, one is something called an algorithm, and the features of algorithms are to be understood in a better way. The instructions in an algorithm must be very simple to understand, or the meaning of the algorithm should be very simple, and maximum the complex algorithms and complex instructions must be avoided. Uh, every instruction of the algorithm must be clear, or should not be any ambiguity regarding the instructions. Every instruction must be effective, or as such the algorithm becomes an efficient algorithm. And finiteness is a very important feature of any algorithm. There should not be an infinity loop as a part of the algorithm. So in that case it is not a better algorithm. The characteristics of algorithm are defined over here. Every algorithm should have a set of inputs. The inputs must be clearly stated, and every algorithm there is a process behind it, and it must be finite. There should not be any infinite loop associated with a particular algorithm, and the algorithm must be effective in terms of the result produced by the algorithm, and there should be a clearly defined output for every algorithm. So these are the basic characteristics of algorithm. As we know, there can be more than one algorithm for a particular problem. So which algorithm must be selected is a very important criteria to be finalized. So for that we have to calculate the efficiency of the algorithm, or the algorithms must be compared each other by means of its efficiency. So the most efficient algorithm will be chosen for a particular problem. So the question is how the algorithmic efficiency is being calculated. uh, Normally the while calculating the algorithmic efficiency, every algorithm has been compared by means of two measurements associated with every algorithm. One is called the time of execution of the algorithm, or CPU time needed for completing a particular algorithm. And another concept is the memory space requirement for an algorithm. So these are the two features which will mark the efficiency of the algorithm. So the time taken must be less, and the memory used by the algorithm should also be very less. So these two factors must be minimum for an efficient algorithm to work upon. So the time complexity, so the time actually depends upon the time of the machine, or the CPU time of the machine, CPU requirement for an algorithm. And if your CPU is very fast and your machine is computer is efficient, algorithm efficiency also will be increased. So suppose in your program there are 10 statements to be executed. Each statement requires 1 unit of CPU time. So 10 statements requires 10 CPU unit time. So that is the time complexity. And another factor depends upon the number of inputs an algorithm has. So if the number of inputs is very low and number of instructions in a particular algorithm also less, so in that case the CPU time needed will be very less. And as far as memory is concerned, the memory for the algorithm, suppose you are writing the algorithm and storing it in a computer, you want to store the program in the computer. So for storing the program you require some memory space. Program cannot stand its own, it should have associated data to work upon. So every algorithm has a program as well as the associated data. So memory space requirement is for storing the program as well as for storing the concerned data. So memory is required for program storage and for data storage. In earlier days of computing, when the memory devices were costly, we were giving more attention towards the memory requirement of an algorithm, that is memory for storing the code as well as for storing the associated data. But nowadays we are not giving much concern to memory because memory components have become very cheap, but we are giving more importance to the CPU time. So time complexity is always been matter of fact than the memory complexity of any algorithm. Now, how the complexity has been calculated is our question for algorithmic analysis. As we have seen, the time complexity is a function describing the amount of time required by the algorithm in association with the size of the input data. So if your input data is very small, then the time complexity is very less. If your data is very large, the time complexity also is a high value. Now, similarly, the memory access, number of memory access requirement in terms of number of comparison, so always is a factor of complexity measurement. And how many times the loops are being executed, that also decides the time complexity of the algorithm. If you have only one loop and it is executed only 10 times, time complexity may be less. Suppose your program has 20 loops and each loop is executed 100 times. So time complexity increases rapidly. Now another concept is it is measured in terms of big O notation. So big O notation has been used for representing the complexity analysis of algorithms. As we have seen, the space complexity function is a function describing the amount of memory requirement both for the code and for storing the concerned data. So in both the cases, the data capacity, the amount of data requirement is a factor actually in the case of memory complexity and time complexity. Now when we have algorithmic analysis, you have to look upon into three situations: the worst case situation, the average case situation, and best case situation. What are these things? Say for example, suppose you are writing a searching algorithm. You are going to search for an element EL in an array of 100 elements. Now suppose the element that you are looking for is at the beginning, is situated at the beginning of your array, say in the first location or in the second location. Then that case is called the best case, because we are searching for an element and it is found at the first few cells. So the searching operation can be finished there itself because we have found out the result. But if it is at the somewhere at the middle of the array, maybe at the 50th location or 49th location or 51st location or so, it is something called the average case because we are accessing 50 different cells for getting into the element that you are looking for. If it is at the end of the array, maybe at the 90th location or 100th location, then you have to search through the entire array to get the element that you are looking for. This is the worst case. So for any algorithm, the same algorithm, depending upon the element that you are looking for or its position in the array, it can be of worst case situation, or it can be average case situation or best case situation. Maybe in the best case it will take only one CPU time or two CPUs time. In the worst case it may take around 100 CPU time, unit of time. So depending upon that, your time requirement of the algorithm may change. Now, as we have seen, the big O notation is used for time complexity analysis of algorithms. Actually, it depends upon, it is being defined as a function T of n. T of n is called the order of growth of growth rate of an algorithm T of n. T of n is equal to order of G of n, O of G of n. Is the order of a function G of n. So the growth rate of an algorithm T of n is defined as the order of a function G of n. So of the order means T of n is less than a constant multiple C of G of n for any n value which is greater than or equal to n0. Say for example, suppose you are drawing a graph like this. So the upper limit of the function, upper limit of the graph is called the order of growth of it is called the growth rate of an algorithm. So suppose you have it is been suppose it is defined as T of n is equal to C into G of n, where C is a constant value and n is always greater than or equal to n0. So T of n is equal to C into G of n. We'll see one example over here. Say for example, suppose in your program, in your algorithm, there are 4 statements. So the number of statements are 4. It is 4. So C is equal to 4. And each instruction takes one unit of CPU time. So the total number of time taken is 4 into 1, 4. So here the order of growth notation is a constant value. Suppose you have a for loop in your program. For I is equal to 0, I less than or equal to n, I plus plus. And there is a instruction inside the for loop to be executed. This instruction will be executed n number of times. So here the order of growth value is order of n. Suppose you have two functions, two for loops, outer loop which varies from 0 to n and an inner loop for j is equal to 0 to n. Here is also one instruction inside the loop. This instruction is executed n into n times. The inner loop will be executed n times for each execution of the outer loop. Outer loop executed n times and inner loop executed for every instruction of for loop, every time of execution for outer for loop. So total number of executions n square. So order of growth notation is represented as order of n square. And so big O notation always represents the time complexity of the algorithm. Now, if you look at the structure of what is the common way of writing an algorithm? So is there any syntax for writing representing an algorithm? Any rules for to be observed while writing the instructions of the algorithm? Yes, there are a lot of rules associated with the structure of the algorithm. So a well-defined algorithm should follow this particular structure. So every algorithm should start with a title. So you start with a title. And you write some parameters over there. So we start with the word algorithm, then the name of the algorithm, and the parameters we are passing to the algorithm as input. It is followed by an introductory remark. Say I am writing as the introductory remarks as this algorithm is used to find the sum of three numbers a comma b comma c. So introductory command is written at the end of the algorithmic title, and it is represented inside the two square brackets, and the input data, the variables are always been represented in capital letters, whereas the algorithm name, the first letter you always used to be capital letter. Now each step in the algorithm must be written with the step numbers, and every step should start with an introductory comment again, and every step should be numbered uniquely. So the first step is initialize step. Say I am initializing s sum to 0. So whenever you are assigning a value to a variable, this left arrow mark will be used in terms of algorithmic notation. We don't write s is equal to 0. If you write s is equal to 0, it is actually a comparison operation. So s is assigned with the value 0. S is initialized with 0. That is the first step. Now in the second step, I am calculating the sum. So calculate the sum. So the variable s is used here. Again s is assigned with a value s is equal to a plus b plus c. A, B, C are given as input as parameters, as we can see over here in the title of the algorithm. So the last step is finished. Always it will be written as finished. And the data, the result, the final result will be returned from the algorithm. Return, the result is yes, return the sum value. So here you have to remember that always the input or output need not be written as printf, like read commands need not be represented in algorithm. Algorithm must always represent the process, not reading some data or displaying some data on the screen. That need not be a part of the algorithm. But several textbooks you can see that they have included input output statements. But normally for a good algorithm to be represented with, we assume that the data is given as parameters to the algorithm and the result is returned back. So these are the normal procedure for representing algorithms. And if you want, you must use control statements like if, repeat, etc. can be represented in an algorithm also. Here some examples are being shown over here. This is for calculating the sum of elements in an array A. You can see the name of the algorithm is SumCal. So it starts with the word algorithm, the name of the algorithm SumCal, and in parameters you have written, in brackets you have written the parameters that you are passing into the algorithm. It is you are passing the array and the size of the array n. array name, and so the array is passed to the algorithm. At the same time, number of elements present in the array also is being passed. So this algorithm, the introductory command is written at the beginning of the at the end of the title, beginning of the algorithm. Then there are 3 steps and numbered uniquely. Step 1 is the initialization step. S is initialized to 0. Second step, you are adding each and every element to the variable S. So for that you use a repeat loop, repeat for I varies from 0 to n minus 1. Since the array is index is been stored as 0, 1, 2, 3, n minus 1, there are n elements, but it index value varies from 0 to n minus 1. So S is equal to S plus A of I. This statement will be repeatedly executed for n times, since it has n elements in the array. And after that, after the step 2 is been executed completely, the control is been transferred to step number 3. Finished is the introductory comment over there, and you are returning the sum value. Here is another algorithm for calculating the maximum value in an array A of elements. Total number of elements present in the array is n. First of all, we are initializing the m with the first element. M is going to be the variable where you are storing the maximum element. Initially, you are assuming that the first element, the array, is the maximum element. A of 0 is been assigned to m. Then from the second element onwards, that is for the index value 1 to n minus 1, you are comparing every element with this m. And if m is less than the a of I, then a of I is been reassigned to m. So here, suppose you have an array A and there are 10 elements in the array. 10 elements in the array. First element is 3, second element is 1, 5, 2, 1, 6, etc. So we are initializing m with the value 3. Then m is compared with 1. Since m is greater than 3, it is not assigned to m. When it comes to the third element, 5 is greater than m, so m is being reassigned as 5. Similarly, the comparison goes till the end of the array, till all 10 elements are being covered, if A of 10 is the array size. So this is an example algorithm. So in this session, we have seen what is an algorithm, what are the characteristics of a good algorithm, how an algorithm can be analyzed, how algorithms can be compared, what are the factors that we will consider as the time complexity and space complexity of the algorithm for comparing different algorithms and selecting the best one out of the available algorithms. So always the complexity of the algorithm, whether it is time complexity or space complexity, it is always related with the number of inputs of the algorithm. And we have seen the structure of algorithm, how algorithms are being written, what are the rules to be rules and regulations or the syntax to be followed while writing an efficient algorithm. So all these things we have seen in this particular